So for question number 1, okay, we have a wagon that is accelerating at 3.1 meters per second squared in a forward direction. I'm just going to make that positive in my givens. Okay, friction is opposing with 87.5 newtons. So that's going to be negative. Okay, and if the mass of the wagon is 32.2 kilograms, okay, what is the magnitude and direction of the pulling force? So I'm going to say applied force here. All right, so my free body diagram then should look like this. 32.2 kilograms, an applied force that way, and a frictional force of 87.5 newtons this way. 1 mark for givens. Okay, the applied force is obviously bigger than the force of friction, or the object wouldn't be accelerating forwards. Everybody okay with that? All right, so if I have the mass and the acceleration of the box, I can calculate the net force acting on the box using m times a. All right, so that's my next step. So m times a is going to be 32.2 times 3.1. Okay, so we're looking at 99.82 newtons. And that's positive because the object is moving forwards. All right, so give them a mark for that step. Okay, if we want to find the applied force, then we have to use the sum of all forces is F net. So give them a mark if they figured that part out. That's supposed to be a 1. Okay, and then we got to solve for FA. So FA will be F net minus the force of friction, which will be 99.82 minus negative 87.5 newtons. Give them a mark if they have either one of those two things written down. All right, that means our applied force to 3 significant figures, 2 significant figures, okay, 1.9 times 10 to the 2 newtons forward. They must have the forward, as that is the vector given in the question. That is the 5th and final mark for that question. Okay, questions on number 1. All right, for question number 2. All right, elevator question. What are the key words in this question? Okay, it is an elevator, but even more important than recognizing it's an elevator, constant speed. What's the net force in this question? 0. Okay, as soon as we realize that, we're good. Okay, that means that the tension in the cable pulling up is the same as gravity pulling down because there's no net force. Okay, so it's 1100 kilograms here, so you can give them 1 mark for their givens. Okay, you can give them 1 mark for recognizing that F net was 0 newtons. Hopefully they have that written somewhere. Okay, so what that means for us then is that F net equals Fg plus the tension. Since F net is 0, Fg equals negative T. Okay, something like that. So all I have to do then, all right, so we'll say give them a mark if they have some kind of sum of all forces thing in here. Fg is m times g, 1100 times 9.81. Okay, so we only have 3 significant figures here, so 1.08. Nope, we don't. I'll tell you why in a minute. (1.08) times 10 to the 4 newtons, and we should have then that this equals 1.08 times 10 to the 4 newtons up. The reason we have 3 and not 2 is because we never used the 4, and gravity only has 3. Gravity is a measured value. Okay, 9.81 meters per second squared has only 3 significant figures. I don't need the number to know that acceleration is 0 if they told me it's a constant speed. I don't actually calculate acceleration using that, right? All right, so that one is out of 4. Okay, so give them a mark there. And then I'd like you to write their mark out of 9 at the top. Let them see it, and then hand them in right here in a nice neat pile.